Hi guys, so today we're carrying on from looking at our reference angles in the unit circle to looking at some exact values. So previously we've just been using our calculator to find values for theta, but there are a few select values where you can always find an exact value. And we do this by using two very special triangles as a proof. You'll love them. So the first one is an equilateral triangle with sides of 2 each, and equilateral triangles all have the same angle of 60 degrees. If we bisect it down the middle, the top 60-degree angles will become 30 degrees on either side of that bisection. And we also can figure out what the height of this triangle is by using Pythagoras' theorem. So a squared plus b squared is equal to c squared. So we've got to find 1 squared plus what will equal 4. 1 squared plus what number squared will equal 4 squared. 2 squared, sorry, which is 4. Now, that, we need to add 3 on there. So 1 squared plus root 3 squared, which is 3, is equal to 4. So root 3 goes in the middle. Now, we can figure out sine, cos, and tan values for 30 degrees and 60 degrees. Okay, so sine 30, if you wanted, you can pause here and actually go through and do this yourself. Just a bit of revision on trigonometry. Sine 30 is opposite over hypotenuse, which would be 1 over 2. Cos 30 is equal to adjacent over hypotenuse, which is equal to root 3 on 2. And then tan of 30 is equal to sine 30 on cos 30, which is a half over root 3 on 2, which is a half times by 2 on root 3, which is equal to 1 on root 3. So if you didn't pause then, pause to this one and see if you can do sine 60, cos 60, tan 60 in your books. So sine 60 would be opposite from the 60 over hypotenuse, which is root 3 on 2, which is actually the same as cos 30. Cos 60 would be 1 on 2, which is the same as sine 30, so there's a bit of a pattern there. And tan 60 would just be root 3 on 2 divided by a half, or multiplied by 2 on 1. So it's equal to root 3, which is just the inverse of tan 30. Okay, the other triangle we look at is an isosceles triangle with sides 1 and 1. So a squared plus b squared is equal to c squared. 1 squared plus 1 squared is 2. Okay, so the side length there, squaring that side, is root 2. Okay, so c squared is 2, so therefore c is root 2. So sine 45, cos 45, tan 45 is equal to 1 on root 2. Cos 45 is also 1 on root 2. And tan 45 is 1 on the other, which cancels down to being just 1, because that's 1 on root 2 times by root 2 on 1. Okay, so this isn't something that you need to remember for a test or anything. It's good revision for using trigonometric values, but what is important is now we have these exact values for 30 degrees, 45 degrees, 60 degrees, as well as the axes in the unit circle, which is 90 degrees, 180 and 360. And of course, we are still using radians. So 30 degrees is the same as pi on 6, 45 is pi on 4, 60 degrees is pi on 3. Okay, now I just realized there's probably not much benefit in me going through each one because we already did the working out here. So if you want, you can skip to the end of the video. Actually, what I'll do, I'll just pause and I'll fill this out. If you wanted to practice actually going through these values yourself, you could fill them out now.
So this is the filled out table, which hopefully you can follow along with once you've copied it out. It's also in your books. The 90 degrees, 180 degrees, and 270 degrees is just figured out using your unit circle from our previous 2 classes. Now, this table is very important, guys. Highlight in your books. You're going to keep on coming back to it because you're going to use it for a whole lot of questions looking at reference angles, which I'll look at in the next video, giving you some examples. Thanks.